And I did enjoy getting a couple of texts from Mackie last night. He was, and this is being recorded, so it's a little shout out to Mackie, since he gave PT the little shout out. He was working on ACT practice and was all proud of himself because he had gotten the right answer. And in fact, I believe his text was something along the lines of, the ACT can't stop this trig genius, or something like that. And it was literally a triangle labeled with, like, the sides were labeled A, B, and C, and it said, what is the sine of angle A? So it was like little a over C or whatever it was, and he was all proud of himself. I was like, oh, Mackie. Hope you enjoyed your 30-second shout out. All right. I would like for your books to not be open. And I heard that you have other teachers who require you to pre-read and take notes, etc. I don't ever want you to do that, because you will probably have a nervous breakdown trying to pre-read some of what we do. But more to the point, I want to guide you towards what we talk about in here, because if I guide you toward it and it's your own discovery, you are far more likely to remember it. Now, we're going to start with something I know you know because I taught you. This, in fact, was where we opened the chapter. Average rate of change. Please don't look back at your notes, but please tell me what the average rate of change is. The slope formula, okay? And specifically, the format in which you should know that is f of x plus h minus f of x over x plus h minus x, which then equals f of x plus h minus f of x over h. Yes? Does the x's go away on the bottom? That is not complicated, is it? Okay. Just to get you comfortable, and I know it's more abstract than you're used to seeing the y2 minus y1 version, et cetera, et cetera. This was a little more complex in its notation, but what did we discuss in 2.1 that the h actually represents?
It's the point between
No, I'm just waiting for you to find your words, because you're doing like little snap fingers in the air, and I'm not sure what that is.
Between A and B.
It's the distance between. Okay, what are A and B? The x coordinates, and that you need to be specific there, because, and the reason this matters so much, and let's do a little sketch here to make my point. And I'm going to draw this segment based on where Madison was doing her little snap fingers. It looked like maybe it was and we'll call it just a line for the moment. But even if it wasn't a line, remember, and I'll repeat the sketch I drew that day. If we have a curve arcing and then dropping again, so it's increasing, then it decreases, what is the significance of my picture when I connect the endpoints with the segment?
That's the average.
Yeah, that's the average rate of change on the interval. And the average rate of change on the interval, the way this picture is drawn, would obviously be positive, right? How do we know that?
It's going up.
Because the curve is climbing the whole time, even though there's a split second when technically it's not climbing, is it? And then, but overall it's climbing. But what happens in between that we talked about that you don't see by looking at the average? What does the rate of change have to do on this curve? It goes from being positive to, for an instant up there, it has to be 0, because then what does it do? It goes negative because the curve starts to fall again. But the path from A to B is a positive one. Does that make sense? Okay. All right. So if this is my A, if the left endpoint is my A, the right endpoint is my B, then the horizontal distance between them is H. And we'll put a little dash line there. So the H represents how far apart your two x coordinates are, right? And the reason that matters, because if you said that, and that's why the words matter. And this is why when you write out a description or an explanation of your idea behind what made you do a problem a particular way or something, becomes so important. Because if you said here the distance between the points, what you'd be finding is the length between the length of the segment AB. Do you see what I'm saying? Which is not what H is. You follow me? Because if I think of this in terms of a right triangle, if I make AB, segment AB, the hypotenuse of a right triangle, then what's the difference between the length of AB and H? What do we know on a right triangle? The hypotenuse is always the longest side, right? And H is one of the legs, which means it would be one of the shorter side lengths, so it clearly can't be the same thing. So you have to watch your language, because when you say it and the point, when you really mean the x-coordinate, or if you're supposed to be talking about the point, and I have students do that all the time, I'm like, give me the coordinates of the y-intercept, and they say, 7, it's 7, it's 7. No, it's not, right? 7 might be your y-intercept, but it's not the point, okay? So that's a pretty big deal at this juncture. All right, so that's our average rate of change, yes? We're good on finding average rate of change. That should be very straightforward. We have a new word for, and I'm going to expand our picture a little bit, and you can either add it onto the picture you just drew. I'm going to redraw a similar picture, but I'm going to start my curve from a further left and then go a little further right position here. All right, and then I'm going to throw a segment across it. Let's see here.
Green.
What's wrong?
Green. Do a green. I'll see if you could do a green segment.
Oh, I thought you said gray. I was like, gray won't show up on the gray background. I was like, why does he want me to draw a gray line? You want a green one?
Yes, ma'am.
Green just for you, Parker. All right, let me pick the right one, though. I want one without arrows on it. Okay, so then I come in through here and throw a green segment on there for Parker. All right, and then we're going to come back to label the points here. All right, so we've got a curve, some function sprawling across space, and I've thrown this line across it. All right. You should have learned in geometry, probably didn't, you should have learned the name of this line. Okay? Okay, I heard the prefix of the wrong one, so we're going to draw a tangent line for Clark and whoever else thought maybe that was a tangent line to show you what a tangent line looks like, if I can approximate that. All right, so we have one segment that touches the curve at exactly one point. We have another segment that crosses through the function so that it intersects with it twice, yes? What's the difference between them? Did you say there's 1 point and 2 points?
Yeah.
You can't answer my question with the question.
Is it like, because it makes like.
What is the name of them?
One is like a chord, isn't it called a chord? C-H-O-R.
Oh, you are accessing the geometry files in your brain. That makes me happy. All right, but okay, a chord is a segment in a circle. A chord is any segment that connects 2 points on a circle. That's what you're thinking of. Nothing. I will give you a hint. Both of these names of these lines are related to. They come from the list of the six trig ratios.
The tangent.
Which one's the tangent?
The one at one time.
The one that touches at one time. Okay, so the blue one is the tangent line. Yes. Yeah, that yellow doesn't show up very well, does it? Let's go back over that. I don't do red unless I have to. All right, that's a tangent line. I just don't like the color. What the heck? It won't make my T. What is my pen doing? There it goes. Okay, there's the tangent line, and this other line, the green line, is the... No, it's the secant line. This is the secant line. So a secant line is what, so if I go back to the original picture, and whether you added this to your picture or not, you should be able to tell me. If I go back to the original picture, which we drew in 2-1, and I replicated here to start our discussion, another name for the average rate of change is the blank slope. Secant slope, okay? So, important moment here. Let's write that down if your pen will write on your paper. Mine is just refusing to. Okay. This is getting on my nerves. Try another spot. Secant slope equals average rate of change. Big idea. And I wrote it so big that I'm about to run out of room to write it. So the secant slope is the average rate of change. All right, now I'm going to erase a spot. Don't erase this off your notes, but I just want to give myself room, see if I can get this thing to write for me. In fact, I'm going to grab my little cloth and see if I can figure out why this pen is fighting my screen. All right, so the secant slope is the average rate of change. Got that? We talked about another kind of rate of change in 2-1. Try not to look back. What other kind of rate of change did we talk about? You remember? Instantaneous. Instantaneous. And that is what the tangent slope is. Okay? So the tangent line slope equals the instantaneous rate of change. Now, I'm going to ask you a question as you write that. And this is just to get the idea, like the seed planted in your mind, not necessarily like, I'm going to ask you this on a quiz or something. But at what point would a tangent line tell me exactly what the function's doing?
Just the point it touches.
At the point it touches the function. All right? Now, I need at least one other person. No offense to Morgan, but I don't want this to be a Morgan and Lisa conversation. I want it to be the whole class talk. Generalize for me how good the tangent line is at approximating what the function's doing relative to where you are on the tangent line. Shall I say that again?
Yes.
Please.
If only I had a replay on here and I could just play it back. I'll have that one day before I retire. Generalize for me how good of an approximation the tangent line is relative to where on the tangent line I am. And when I say an approximation, I mean an approximation of what the function value would be.
It will be like better the closer you get to like where it like touches.
Exactly. The tangent line is going to be better at approximating what the function's doing the closer I am to that point. Doesn't that make sense? Okay. And in some functions, you'd have to zoom way in to see where the difference is because just the shape of the function. You know how some functions almost go flat in spots? If you could get a tangent line through there, it would be very informative on some interval. You follow me? But the further out I go, the less it's going to tell me. Because clearly, since this tangent line goes through what appears to be close to the maximum value up there, right, of that function on that interval, then to the left of that point of intersection, the function itself is climbing, and my tangent line slope is positive, so that would be a good correlation between the two, right? Although it may not be a great approximation. All right, but then when I go to the right of that, what's going to be a pretty decent approximation? Does that make sense? Okay, these are just general ideas. We're getting to the specifics. And I will tell you that the devil is in the details in this lesson.
On a tangent
Here it
line,
is. I'm sorry.
Can you go through it on a tangent line, or do you have to just touch it on that side?
Let me come back.
Through the
Can you like intersect it? Or?
Well, the tangent line intersects at one point. Okay, even if you just slide in just a little bit so that what you think is the tangent line, if it's intersecting that function at more than one point, it's no longer a tangent line. Now it's a secant line. Because it's either going to be one or the other. Right? Does that make sense? Is everybody good with that? Okay. And I've kind of gotten out of order of what the book says, so if you get confused by that, we'll talk about it later. But here's the big daddy. And I'm just going to tell you, this is one that seems simple on the face of it, but it will cause you some grief in the coming days. This little definition that I'm about to write is one of the, if somebody had to list the first nemesis in calculus, it would probably be this definition, okay? Now when I write the definition, I want to hear what you think about that, okay? And then it is in the examples that you will go, oh, this is what she was talking about. Okay, slope of a curve at a point. Very, very important definition. It's one of those things that when I teach you later, the shortcut way to do what we're about to do the long way is say, why, by all that's holy, did we have to do that god-awful process of doing it the long way? Well, there's so many things in math that you don't really understand what's happening if you do it the short way from the beginning, yes? Okay? So, here we go. Well, in fact, before we go any further, we just talked about this, didn't we? What in the picture we just drew, where were we looking at possibly something that could tell us the slope of that curve at a point? The tangent line, right? Where does it tell me the slope of the curve? At that point, right? Okay. And remember last year in pre-cal I told you you'd have to write lots of equations of lines this year? And you really need to know point and slope form to save your sanity? This is what I was talking about. This is where you get introduced to that idea today. Alright, so the slope of the curve. So we're going to leave out that phrase because we've already written that in the term itself. For y equals f of x, so we know that this is a what? A function. At, and I'm not going to tell you what this is, I'm going to ask you what it is. A, f of a. What is that animal?
Yeah.
It's a point. Yes? A, f of a is just a point. Okay. M equals, and what is M?
Slope.
And guys, this is a really big moment in your education because what is the slope always made you think of? You are about to jump off that cliff and sprout wings because we're going to be able to find the slope of anything. Everything has slope. Okay? So, here we go. And I'm going to write the first piece, and then before I write anything else, the limit as h approaches 0. Now, how did you know there had to be a limit in this definition? Because we're in chapter 2. Yes? Okay, well, what does this mean before I write any more? Whatever we're about to write as h goes to 0. And we've been talking since 2:1 about what h is. What is h? The distance between the two x values, yes? So I want that distance to get really, really close to 0, right? Look at your picture and tell me why we want that to be 0. The picture that we sketched a while ago. If I've got a tangent line that touches a curve at one point, and what did we say about how good of an approximation that line's going to be? The closer it gets to the point, the better approximation it's going to be, not only for the function value, but the slope of the curve, right? But it's going to be, it's not only going to be close, but at the point, it's going to tell you exactly what the function's doing, right? Doesn't that make sense? Because I got my slope at that point, because that's my instantaneous rate of change, which is the slope of that line, right? We wrote the tangent line. The tangent slope is the instantaneous rate of change. All right, so I know what the function is doing at that point slope-wise, and the y-coordinate is the same for the line and the point by definition, right? You see what I'm saying? So I want to be really close to it. Why do I want to be really close to it? Because what happens when I get further away? It's not as accurate. The further away I move from my point of intersection, and that point is called, from earlier in the chapter, the point of tangency, I think. Or maybe not earlier in the chapter, but definitely in previous knowledge, right? Doesn't that make sense? It's the point of tangency. At the point of tangency, the line tells me everything. The further away from the point of tangency I move, the less it tells me. Make sense? Okay. So here we go. F of a plus h minus f of a over h. What is that? What are we taking the limit of? The slope. Okay? So we're forcing h to be 0. All right? Now, as a necessary thing to get embedded in your brains, just from conversations I've had with several of you over the last 24, 36 hours, why can't, or what would be the first thing I should do if somebody hands me one of these to do? What is my first attempt at finding a limit? Substitution. Okay? How do I already know that substitution is not going to work on any of these? Because h is in the bottom. So this lesson is about how to get h out of the bottom. Which is what's going to happen is that's going to teach you how much algebra you don't know. And it's going to force you to reconcile the fact that parentheses matter and such as that. Okay? All right. Before we get to some examples, though, let's finish up our little terminology. This, I'm going to write something and I want you to tell me what you would call it if I didn't tell you otherwise. F of a plus h minus f of a over h. And I want you to write it separately just to remind yourself that this is a very important little ratio here. What is it we have just written? Well, the secant slope, standing by itself, it is the secant slope, right? Because that is the slope between A and B, right? And B is being called A plus H, right? Because B is H away from A. Does that make sense? Okay? So this is actually called, it has a name, the symmetric difference quotient. So a very important distinction is made by writing this as a separate thing, and that is that if I leave off the limit, then what I'm really finding is an average. If I put the limit on there, I'm finding an exact value using limits. Okay? So that's, it seems like a little thing, but it's a huge thing. And you got to go back to that picture to see what the difference would be there. You with me? You don't look very with me. Some of you look like you left the building 2 or 3 minutes ago. Okay, one more term we need to add to our little laundry list here, and this is one you should already know. What is the normal line of anything? Don't everybody answer me at once, please. I can't process all this auditory information. No one? No one knows what a normal line is?
Straight.
There's like X or just like the number.
We'll just go with the fact that y'all are clueless, okay? A normal line is perpendicular to the tangent line. For our purposes, that's all we care about. Normal means perpendicular. Oh, my goodness. Perpendicular to the tangent line. So let's think for a minute. If I handed you a picture and said, write the equation of this tangent line, given that this instantaneous rate of change at the point is 7. Okay, well, how would you write the equation of a line if I told you the slope is 7? And what else are you going to have about the point? You're going to have the coordinates, right? Because if it was like negative x squared, and I said at x equals 4, how are you going to get your y? Plug it in, okay? That's a very important question, because that's the reflex that needs to be there if it's not already. So if you were going to write an equation of a tangent line, then for that point, for that example, it would be y minus the y coordinate, not if you agree, equals 7 times, if I told you that that was the instantaneous rate of change at that point, x minus the x coordinate, right? There's your tangent line. Okay, well if I've got my tangent line, why would my normal line come for free? What's the relationship between perpendicular lines and their slopes? Negative reciprocal. So if the tangent line slope is 7, what's the normal line slope? Negative 1 over 7. Simple enough? Okay. All right, that's pretty much it as far as notes. Let's do some examples. This is where it gets real. Would y'all like a separate video of the examples and the notes, or you like it all together? Okay, the all together spoke first. We'll go with that. All right. So as our first example, let's do number 2. And this really isn't, and the beginning examples a lot of times aren't really a full example of the whole concept. But our function for number 2 is f of x equals the square root of 4x plus 1. And there's a part A, part B. And the directions here say find the average rate of change of the function over the interval. And our interval for A is 0 to closed.
Can you open my books now?
Yes, you can open your books now to page 92. And what I would like to have happen And while you're getting your books out, let me get a quick show of hands. How many of you, when somebody describes something, you start seeing a picture or a movie in your head? That's a surprisingly small number of you, because that's about half of you. I see everything in my head, which is why when you tell me something nasty, I'm really revolted. Because I'm seeing what you're saying, and I want to punch you for telling me. Okay? Mr. Lawson loves to tell me things on a daily basis that I never wanted to hear. You need your next book? Yes, sir. I believe it's volume 10, if I remember.
Oh, stretching. Yeah, I'm pretty cool. I mean, I'm pretty hot, but I mean, it's cold in here.
How's it going, Mr. Gallimore? Kind of quiet today. Okay. So the reason I ask about the the visualization, the video in your head, which is what I would see, when I see this and what I want to have happen, and the more sophisticated you get in seeing, you'll start to see what the function would look like. What would this function look like, by the way? It's the square root graph, right? It's just a modification of the square root graph, and we could get into the particulars, but it's going to have that shape, yes? So if I draw a line that starts at 0 and then goes through what happens at 2 on the x-coordinates, then I can imagine that there will be an intersection on a curve, right? Wouldn't that look a lot like what we sketched? Just if you just look at the secant part of it, the very first one we sketched, the one we did in 2-1, see a picture in your head. The more you see the pictures in your head, then the more you're going to understand this. If you are not a visual person, if when I said when someone's telling you something, you automatically see a picture in your head, you may not need to do this. But if you're one of those people that there's no picture that forms, you're just like, there's just gray fuzz in your face, right? You should pick up your calculator and graph the thing, and then look, and if you're writing an equation of a tangent line, you should graph the tangent line on there. If you're graphing a secant line, if you're writing the equation of a secant line, you should graph it on there so you can see it. You see what I'm saying? So really go that extra step, because this is a really important foundation to everything else we're doing. And this wraps up chapter 2. All right, the directions here say find the average rate of change. So what would be average rate of change be here? Well, the first thing I'm going to ask you to do is to actually write AVG period. So an abbreviation. And then you can do capital R, little o, capital C equals. And if you wrote that on the AP exam, any AP scorer would know that that's what you meant. Okay? Or if you want to write the words out, that's fine too. Okay? Well, what is the average rate of change? And we'll just call that, for now that we know that there's more slope than the slope we knew before we got here today, from this moment forward, let's call that the 7th grade slope. You good with that? All right, so this is just 7th grade slope. So that means I'm going to need f of 2 minus f of 0 over 2 minus 0, yes? Now, do we need to write that to know what we're doing? No, we don't, but I want it there as evidence of where your next step's coming from. Okay? So then that equals, well, where do I get f of 2? You plug 2 into the function. Well, if I plug 2 into our function, I get the square root of 9, don't I? Which is more affectionately known as 3. What happens when I plug in 0? 1. So that gives me 3 minus 1 on the top, 2 on the bottom, 2 over 2 is 1.
Wait, can you go over the last part again? Where'd you get the 3 from?
We're just substituting 2 into the function,
Okay.
right?
Did you just take like a positive value because like you square it and once you get like plus or minus? Did you just take like a positive?
Yes. You take, well, when you're substituting a value, it's not going to be plus or minus. It's going to be specifically what you get when you plug that in, right?
Okay.
Y'all with me? Okay. So that's my average rate of change on that function. Yes? And then B, same function, different interval. So for B, our interval is from 10 to 12. So our average rate of change is, and this is just what I teach my Algebra 1 students to do. I have them go ahead and set up the bar with the minuses. And if you're subtracting anything, like if you're going to show your work, if you're plugging into a polynomial, then you need parentheses after that minus, because it's distributive to every term. But this one only has one term. All right, so what am I going to write first on the top?
F of 12.
f of 12 minus f of 10 over 12 minus 10. All right? And you'll have some functions where you need to do some work on paper to compute these values, where obviously when you look at one this simple, it's pretty straightforward. All right? But f of 12 would be the square root of 4 times 12 plus 1, which is 49, which gives me 7. Yes? How about 10? The square root of 41 over, and we're done. Why are we done? Because you're going to get an ugly decimal. We don't want ugly decimals. If you write decimals on a test or quiz of mine and you don't show at least 3 places of accuracy, it will be marked wrong. Why? Because that's what they do on the AP exam. May as well get started on it now. Yes?
Okay, so the function that we're doing is the same as what we were on, not like the x, I mean f of x plus h, right?
Yes.
Now, where's like the a? Let me read
Okay,
some
well, let's go
questions.
back. No, it's not a stupid question. No question is stupid at this juncture. For sure, you want to ask those questions to get clarity, because I want y'all to be crystal clear on everything we're talking about now, so that it doesn't haunt you through the course, because this will haunt you through the course if you don't get it straight now. Let's come back to our picture that we labeled on the very first, at the very top of your notes, all right? And you can come back now, and I'm actually going to put this in red, although I don't really like red. In fact, let me use if I'm going to use red, I'm going to at least use a darker red so it's not as revolting. The coordinates of B, in fact, let's write them in the blue that I wrote the point in to start with. In thinking in just terms of B and what we just wrote, what would the coordinates of B be? B, f of B, right? Okay. Well, another way to refer to this point would be now B relative to A is A plus H, f of A plus H. Do you see that, Madison?
Yes, ma'am.
Okay, why does that make sense? Because what is H?
The distance.
The distance from my left endpoint to my right endpoint, x coordinate, right? Okay, so if, let's just say that A was 4, and I told you we're going to move 3 steps to the right, where is my H in that statement?
The 3 steps.
No, my H. My H is the 3, right? So my B, which would be A plus H, is 7. Does that make sense? Is that cleared up?
Yes, ma'am.
Cool.
Right,
Yes.
Going back to the last problem, when you got f of 12, did you do 10? You did 10 plus 2, right? To get the 12, like 10 because it's the A, and then do you not see what I'm talking about? When you got f of 12 to start it off with, because I was looking at the formula and I couldn't figure out how.
Okay, the denominator came from 12 minus 10. But when I plugged in, when I did f of 12, is that what you were saying?
Yeah, like how you got the 12 for that. You got, because you did the 10 and then the H would have been 2, right? So you did 10 plus 2. No.
Yeah, but no, but that's what she was asking.
Okay.
She's saying, okay, y'all are really asking the same question.
Okay.
Because on this interval, remember from pre-cal, when we denoted intervals, it was either AB with parentheses or AB with brackets. What is the distinction between these two? One of them we include the endpoints and one doesn't. No, but we're talking about it as intervals. These are intervals, but okay, I can see where you call that a point. But these are both intervals. As intervals, what's the distinction between them? First one, we're not including the endpoints, right? And the second, we are including the endpoints.
Okay.
Y'all with me?
Yeah.
Okay, so back to your question. Another way I could write this, if you were following what Madison's question was relative to the way we relabeled that picture, I could rewrite this one as A, comma, A plus H, couldn't I? And obviously it would be the same for the bracket one, but just brackets, right? So in this instance, when they give me both the A and the B, they're really giving me H, which is
Okay.
the difference between the two, right? Excellent questions. Tells me you're really thinking about what we're doing. That makes me happy. All right, I would use Garnet, but I don't want to offend my Clemson peeps. Not right now, anyway. Not what I'm trying to teach you. Alright, let's jump down to number 10, which is over on page 93. And we're jumping over a lot of stuff there that at a glance might look scary, but I'm just here to tell you all of that in there is just application of the regular old 7th grade slope formula. And if you have trouble with it, then we'll talk about it when you get there. Alright, so our directions for 9 through 12 say at the indicated point, find the slope of the curve, an equation of the tangent, an equation of the normal, then draw it with the tangent line and the normal line in the same viewing window. So here's what we'll do. We're going to do all the analysis on screen here, and then I'm going to stop the video and go over and we'll graph it together on my software while you graph it on your calculators. And you'll understand why I said a minute ago, even when it doesn't tell you to graph them, you should graph them so you can start getting these whole relationships locked down in your head. Okay, I know that was great grammar. These whole relationships. Ms. Rumlett would be proud. Y equals x squared minus 4x at x equals 1. Alright, so my first job for part A, and I'm not going to write all the steps out as far as what we're supposed to be doing, I mean, on the instructions. We're supposed to find the slope of the curve. Well, when they ask you for the slope of the curve, they're talking about at the point you're given, okay? So how do I find the slope of a curve? The slope of a curve. Let me take you back to the appropriate place in your notes. It is the limit as h approaches 0 of the what? Symmetric difference quotient, which is really the 7th grade slope. Yes? Secant slope is correct, but does that inform your brain? What does 7th grade slope do? That kind of just jumps right at you. Oh, that's all I'm doing, right? So the slope, which I am here to find, is the limit as h approaches 0. And let me just tell you, this is where part of the nightmare begins. If you don't write the limit as h approaches 0 on every step until you get to until you actually take the limit, you're not going to get credit for your answer. Because you're saying, I think that the instantaneous rate of change and the average rate of change are one and the same. And we've established that that is probably not true, right? Just from that simple little picture we've been talking about since the beginning. All right, so we're going to do the limit as h approaches 0 of what goes on top? F, and let's write the F version and then we'll come back and fill it in. F of 1 plus h minus f of 1 over 1 plus h, if you want to go that far, minus 1. Yes? Because if you write it that way in the denominator now, it'll help you remember over the course of the year, and next year when you're sitting in a college class, that denominator is just the distance between the two x's. Okay? Because h is going to feel mysterious and evil at times when you're fighting with it, but that's all it is. Okay? And if you remember that that's all it is, that sets you up for how to find it when you need to find it. All right? So here we go. We're going to write the limit as h approaches 0, and now we're going to actually write this out. So what does f of 1 plus h mean? What are we about to do? We're about to plug 1 plus h into the given function. Yes? So that's going to be, in this case, disregard that. What's the first thing I do with the x in this function? 1 plus h squared. And what else does this function do? Minus 4 times 1 plus h. And what have I written so far? What is all of that? That's f of 1 plus h, right? And then what do I have to do? Minus, and this is a two-termed animal. If it has more than one term, you must put parentheses. And if you're worried about counting terms, just always put this second piece in parentheses. Otherwise, you will be wrong. Because you will miss it. Because you won't distribute the minus and you'll get the wrong answer. And you'll have this beautiful page of meticulously done work that leads you to the wrong answer. And it will make you want to cry or say words your grandmother doesn't like to hear. All right? So then what do I need to do? Plug in 1. So I get, and I want you to write this out. It won't make sense now, but later you'll understand, maybe. And if not, then I'll explain it to you if you still don't, if you're that slow. Just kidding. And me and this pen. There's a square. All right. So it's 1 squared. I want to be the writer. Y'all should be telling me. What should I write? Minus 4 times 1. And what is that? So if one, don't close parentheses. Because actually that's just what? Oh no, I'm sorry. This is, I'm getting ahead of myself. I'm thinking I'm on the next step. Sorry. Okay. And then I'm going to put all that as my numerator because it is. Yes? And what's on the bottom? 1 plus h minus 1 is h. Boom. I will ask you again, because we actually had this conversation like in the notes earlier, but it was an abstract. Why can I not do what I want to do? Because this is a limits problem, and I'd love to be able to do it because that makes it really easy. I can't plug in 0 for h, right? So now let me show you another little shortcut that's going to be your very best friend in these kinds of problems. Let me pause. So the trick I want to show you is that on all of these problems, you're going to start off with this same lovely looking thing that you have to simplify. I would recommend that you take that h off the bottom. Dividing by h is the same thing as multiplying by 1 over h. So pull that out front. So all we're going to be working with is the numerator. And we'll keep writing the limit as h approaches 0 of 1 over h until we get this stuff in the top cleaned up. Now something beautiful is about to happen if your algebra is right. And this is very important because if this thing that's about to happen doesn't happen when you're doing one of these problems, you're doing it wrong. Stop here and figure out what you did wrong, okay? Because it's probably some silly little algebra thing you messed up. All right, so I'm going to take a big deep breath. What is 1 plus h squared? Yay, 1 plus 2h plus h squared. If you can't expand a binomial that quickly, you are behind and you need to catch up. Okay? And then we have minus 4 times 1 plus h. So what's that going to be? Minus 4 minus 4h. Okay, well obviously this is minus 1 plus 4. Close parentheses. I will pause and make sure you're with me on where all the terms came from, and then I'm going to show you what magical thing I'm talking about happening. Everybody see where all the terms came from? Okay, so now look. And the reason I wanted you to write this out in broken out form is that ultimately we won't be plugging in a number. We'll be doing this with just an x where the 1 is. Okay, but I have a 1 at the front. What else do you notice of note? We have a minus 1. These two took each other out. And then I have a minus 4 and a plus 4. And now what do you notice that all of the terms that are left now have in common? They have h's. Okay, that's vital. Okay, so we have the limit as h approaches 0 of 1 over h of, and then I have 2h minus 4h, so that's going to give me negative 2h plus h squared. Everybody agree with that? All right, now this is where, and how much of these last steps you write depends on how much you understand about what you're doing. All right, so, but you definitely have to keep writing the limit as h approaches 0 until you take it. And here's what I want you to write. I want you to write negative 2h plus h squared back in the numerator and put the h on the bottom.
So you
Now-
reversed it? Like you took it back?
Yeah, I took it out as a multiplier just because, and this was a fairly straightforward one. Some of them are going to take more steps, and it gets really, you know, on a piece of notebook paper how aggravating it is to have to keep writing something that's got a numerator and a denominator. That 1 over h out front is the trick to keep from having to take up 3 pages of homework, notebook paper to do it. You with me? All right, now, I still can't plug an h, right? But what I can do when I have a single term in the denominator is that I can I can divide each term in the numerator by the denominator now, right? Because that h is distributive. All right, so when I do that, I'm going to end up with the limit as h approaches 0 of, what is negative 2h divided by h? Negative 2. What is h squared divided by h? H. So what I'm left with is negative 2 plus h. You with me? Yes? Okay. And can I plug 0 in now? And what do I get? -2. That is the slope of this parabola at 1. Okay? You've done the nasty part. Everything else is easy in this problem.
That was fun.
Okay? So now we're going to go to part B. Part B is an equation of the tangent line. And I'm going to ask you what will become a question you get sick of hearing me ask, if you can answer it today.
Maybe that was just one part of it.
That's why if you look on eChalk or the Google Calendar I sent you, we're spending 3 days in class on this. So you'll have 2 work days on this in class. Okay? Not that I should coddle such whining, but since I'm recording, I'll be grown up about it. All right, the question I want to ask you is, if I'm going to write the equation of a line, what pieces of information do I need? The slope and a point, yes? All right, what is typically the most tedious part from back in the writing equations of lines days? Figuring out what your slope is, right? It's just plugging into that formula. Didn't we just do that? So now we know from part A that our slope is -2. And we have half of our point, yes? Because they told us to look at x equals 1, yes? Well, where do I get my y coordinate? Plug it into the function. So this is 1 f of 1, so write that in your notes so when you look back, you know, it goes, wow, how did we know that that was our y? Okay? And y'all will be telling each other this at some point. All right? Maybe even tomorrow. What is f of 1 in this case? It would be 1 minus 4, yes? AKA -3. All right, so that's 1, -3. So now we have a point, we have a slope, so we write our tangent line. So we write y plus 3 equals -2 times x minus 1. And there's our tangent line.
Wait, can you explain to me what just happened up there when you found that your thing was negative, your y coordinate was -3?
What does f of 1 mean?
It means your y when x is 1.
That's right. So how do I find that? Anytime. If I said, Madison, compute f of 1 for me, how would you do it? You don't need to let your voice trail away, because if you're asking, there's probably 10 other people that are like, what the heck is she doing? And they just don't want to be the ones to ask. You just plug 1 into the function, right? Our function is x squared minus 4x.
Oh, okay. I saw that. Okay, I saw that -2 up there. I was like, what do you do with the -2? And there's nothing else, and she just got -3.
Well,
Okay.
where did we get the -2? From part A, right? That's what A was all.
You just threw that up there, and I was really just, okay. I feel better now.
Good, I do too, because I was scared for a minute. All right, part C. Madison, let's go back to 7th grade. Just kidding, of course. Okay, now we want to write equation of the normal line, okay? So now, and this is very important to me that you do this. What was that m equals -2? What did that tell us? The slope of what? The tangent line, also the slope of the curve itself at that point, right? Okay? But on this one, we want the normal, so you're going to put an m like we always do and a subscript perpendicular symbol. Okay? Or you could actually write the word there. You could write m and your subscript could be the word perpendicular. I just don't like to write that many letters if I don't have to. So I like symbols better. So this is our perpendicular slope. If the slope of a line is -2, the slope that would be perpendicular, 1/2. What point are we using? The same one, if my board will stop going on strike here. 1, -3. You keep the same point, yes? So my equation is y plus 3 equals 1/2 x minus 1. So let's just say this is a test question and you write the tangent line and then suddenly can't write the normal line. I'm going to be very frustrated. Do you see why? Because part C is really an Algebra 1 question, isn't it? Okay. And then for D, and I'm just going to write, let's go graph, exclamation point. And that's going to end our notes and our recording.